dealing with ratios and proportions. There's a couple of things that we are going to cover here. The first thing is we're going to compare our ratios. I'm going to give you two ratios and ask, are these equivalent ratios, are they or not? And you're going to have to decide that. The second thing is we're going to solve proportions. A proportion, which you will learn here in a second, is when the two ratios are equal. So some of them will be set up as an equation. Some of them are going to be proposed to you as word problems where you're going to set up an equation and solve yourself. And we'll cover both of those things today. So let's first talk about what a ratio is. A ratio is a comparison of two numbers by division. So typically we see a ratio written this way, as x divided by y. But either of these other two things are other ways you might see a ratio. Again, guys, your handout does not have all of the examples, all of the notes. You might want to put some of them either on the back side on the blank side, the blank space, or in your notebook. A proportion is an equation stating that two ratios are equal. Equation stating that two ratios are equal. So we've got a couple of new definitions there, ratio and proportion. We are going to next look at a couple of ratios and decide if they are equivalent ratios or not. You can wait a second. You can go back to ratio. Remember, a ratio is a comparison of two numbers by division, and a proportion is an equation stating that two ratios are equal. Here's our first example. Again, this is not on your handout, so you might want to write this down. It says determine whether 2/3 and 16/24 are equivalent ratios. Write yes or no, justify your answer. Right, so what we want to know is 2/3 equivalent to 16/24. Equivalent means they're the same, they're equal. There's a number of different ways that we could determine this. The way that I'm going to encourage you to do it today is to use what we call the product of the means and extremes. What that means is we're multiplying one numerator times the opposite denominator. So 2 times 24 is 48. We want to know, is that equal to the product of the opposite mean and extreme? So 3 times 16 is? They are equivalent. So we would state that yes, these two ratios are equivalent. So I'll be looking for two things. Number one is for you to answer yes. And the second thing is to justification for your answer there. If you tell me that 48 equals 48, that's justification enough. That will work for me to know that it doesn't have to go.
Whenever you cross multiply, can you put it beside the number that, like, two numbers?
Put it here?
Yeah.
Absolutely, that's fine.
Okay.
Now, there are other ways that you guys probably know that you could compare these two ratios. What's another way that you could determine if they're equal or not?
Couldn't choose.
I don't know. I'm just not used to that.
Simplify.
Simplified? What do you think it's simplified like? Correct me if I'm wrong. Are you thinking 16/24 is a fraction that could be simplified? You're thinking, okay, that 8 goes into both. 8 goes into 16 twice, into 24 3 times for 2/3. That's one way. Absolutely. Addie, what's another way?
Before you cross multiply, could you like change 24 and 2?
You're wanting to
So-
simplify those?
Yeah, to 1 and 12.
Okay, if we were going to do that, we do that when we multiply fractions.
Okay.
We could do it that way, but in our case, we're not multiplying the fractions, but instead we're multiplying the means and extremes, so we couldn't do that. There's another way way that I know you guys know that you would compare these. How about a decimal? You guys can change it to decimals, right?
Huh?
Decimals? If I gave you 2/3, could you make that into a decimal? 2 divided by 3, 0.6, repeating, right? What if we did 16/24 as a decimal? You get the same thing? Okay. So there, right there, we know that they're equivalent, correct? Here's the issue with these two ways of determining if they're equal or not. I have some students that will like to try this third method, and they'll say, okay, if we have 2 divided by 3, well, that's 0.6 repeating, but then they'll round that. What would they round that to? 0.7. Which is legit, I mean, we would round to 0.7. But then they might have 7/10, and if you take that to a decimal, what is it? 0.7. Are these two equivalent ratios, though?
No.
You know that 7/10 is not equal to 2/3, don't you? But if you round your decimal, then that totally changes things. So I don't encourage students to use this third method just because of that rounding error that I see a lot of times. Now, the second method that we discussed, this will work, simplifying your fraction, as long as your numerator and denominator are integers. But what are you going to do if they become decimals? Then it becomes difficult. You can't necessarily simplify as easily. So multiplying means and extremes is probably the best way to do this. So with that being said, I want you guys to try this one. I want you to use the product of means and extremes. You have a clicker so you can send in yes or no. A is yes, B is no. Just to verify how we got our answer, did you do 3 times 14?
Yeah.
3 times 14 is 42, and 7 times 9? They're not equivalent, so of course no is the right answer. I would like for you to try letter A also. Letter A. Determine if the two ratios in letter A are equivalent or not. Be sure to justify your answer.
We can tell it. Do we have to write it down?
I do want you to justify. I do want you to justify. 6 times 5 is 30, and 2 times 10 is 20. Of course, they are not. Make sure in your homework that you're stating no, and then you're showing maybe that product you got when you multiplied. The means and extremes. Okay, so like look at example A. This one is not as obvious, is it? Whether they're equivalent or not. This is why I want you to show your work. I want you to get in the habit of doing this process so that when you get to more complicated examples, you'll be able to work through the decision of that process. Let's multiply our means and extremes here. 0.25 times 2 is 0.5. And then multiply 0.6 times 1.25. So these are not equivalent ratios because the product of their means and extremes is not the same. Okay. You guys try the next one, please. I need one more in. 2 times 20 is 40, and 2.5 times 16 is 40. Yes. These are equivalent. Maybe just have to do wrong with your calculator. Alright, let's keep going. Example A. We're going to, in A and B, we're going to solve each proportion, if necessary, round to the nearest hundred. So what they're wanting to know is what value can you put in for x so that these two are the same. Can you look at this and tell?
Yes.
What is it?
6.
6. Okay, so how would you do it algebraically?
10 times 3 divided by 5.
Okay, so if you set up an equation, 10 times 3 is 30 equals x times 5. 5x. Could you solve this equation? Divide by 5. 30 divided by 5 is 6. But you guys knew that looking at it. That's good that you're able to think and reason that the answer is 6. Look at example B. A little more challenging. Let's see if we can't work it out. We have some algebra skills that we could use. Let's cross multiply here. 7, 6, 7x, 7 times negative 2. Negative 14, gonna multiply 7 times each of those numerators, equals 14 times 2, 28. Now what you solve? Add 14. 7x equals 28 plus 14 is 42. Divide both sides by 7. X is 6.
What I did, I just, to make 2 7s into, to make 7 into 14, multiply by 2, and then 2 times 2 is 4, and x minus 1 plus 2 equals 4, so it's 6.
So you were just thinking backwards with it. That's good. That's awesome.
I'm awesome.
Look at example B. I want to do another one where we've got 2 terms there in that numerator. Let's go ahead and cross multiply. 5 times 3 is 15. Here we have 8 times x. 8x, and 8 times 4, 32. What would you do to solve? After 32. 15 minus 32 is negative 17. Divide both sides by 8. Negative 17 divided by 8 is
Negative 2.125.
You may not get nice integer answers. You may get a rational answer. Just it's okay. Okay, I want to go now to the examples that are on your handout, which are the word problems. We'll go through a couple of these together. Is this your first one?
Yeah.
Bicycling. The gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. Suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have to crank the pedals during the trip? Let me first explain what's going on. You guys know when you pedal a bicycle, you've got to pedal your feet more times than the wheel spins. You get that? Because the wheel's bigger, takes longer for it to go around, whereas the gears are smaller. What's that?
Is it 2,896?
2,896.
Yes.
So I want you to set up a proportion. I want you to show this algebraically. What is the ratio that you know? 8 to 5. And please write this into your notes so you've got some good examples. 8 to 5. What is 8 representing in this ratio? Turns of the pedal. So I'm going to write that as pedal turns. What is 5 representing?
Wheel turns.
Wheel turns. Now, they want to know how many times would you have to crank the pedals if the wheel turned 2,435 times. So you know that the wheel turns is 2,435. Do we know how many pedal turns that's going to be? No. This ratio, we only know one of the values. We don't know the other one. Notice that here in the denominator I have wheel turns, and the numerator I have pedal turns. You may have flip-flopped that numerator and denominator. That's fine as long as you do it in both ratios. Is this okay? I set it up? So then solve. So let's cross multiply. 8 times 2,435 is 19,480 equals 5 times x or 5x. So we divide both sides by 5. X would be 3,896. 3,896 what? Turns of the pedal. Say pedal turns.
I just divided 8, I did 8 by 5 times 2,435.
That's fine, you just have your rate. In the next one. In the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? Well, what's the ratio that we're given? 2 to 232. 2 is representing the number of years, and 232, number of stores. So let's set up a ratio that we want to find its equivalent. We want to know the number of stores, x, in 3 years. Again, we could have flip-flopped this. We could have put our stores in the numerator, our years in the denominator. Let's cross multiply to solve. 2 times x is 2x, and 3 times 232, 696. We can solve by dividing by 2. 348 stores is correct. Be sure to label your units. Want to do one more? It takes 7 minutes for Isabella to walk around the gym, track twice. At this rate, how many times can Isabella walk around the track in half an hour? What's the rate or the ratio that we know?
2 or 7 to 2.
It doesn't matter, you could flip it. 7 minutes to 2 laps. We want to know how many times, how many laps, she can walk in half an hour. What would we use for half an hour, Dawson? 30 minutes? 30 minutes. 8 minutes for our numerator, laps are in the denominator. Cross multiply to solve. 7 times x, 7x, and 2 times 30, 60 divided by 7. 60 divided by 7 is 8.57. 8.57 what? Laps. As far as rounding is concerned, the directions will tell you where to round. Make sure you are looking for those directions on your homework. Alright, I am going to stop here. I know there's a few things we didn't get to, but that's okay. We've got 3 really good ones that we went through. You do have some problems out of your book to try. It's on page 115, 9 through 33 all. Let's utilize our time that you have remaining. You guys are always welcome to come in during advisory for a quiet place to work, or if you want help. Check your answers for your evening.